Hi, and welcome everybody. Happy to see you could join us for today's webinar, where we will be discussing the topic of automating cloud management and is there a room for automation community. Should you have any questions, post them in the Teams chat. We'll answer questions in the end of the presentation. And also, please remember to keep your microphones muted to ensure smooth presentations. Thank you. So, with you today are Jose Juhala from AWS, Santtu Seppänen from Solita, and me from Solita. A little bit about today's agenda. First, I'm going to take a look at the challenges we have faced working with our customers and what we think can be a solution to these problems. Then Jose from AWS will give you a quick status update of current and future state of cloud automation. After that, Santtu will describe about value creation and how cloud can be utilized as a tool for customers. Finally, we have room for discussion and agreeing next meeting, after which we are going to answer to your questions. Okay, so let's get started. Briefly about myself, I will not spend too much time here, but background in telecom software and business. I have worked for 10 years in telecom industry before my Solita career. Now worked for Solita 5 years. Product management and development have been pretty much my background in business side. Also working pretty heavily with organization IT. Hobbies including fishing, sport with kids, building houses. Hopefully this is the last one, but like they say, when you build the second, it's very probable the third will come, but let's see. And of course, home automation is a very interesting topic also. All right, but the problem? We see in the market around cloud adoption that it consists of the following. First, slowness. Setting up cloud foundational requirements for customer or organization professionally can take up to 100 workdays or even more, with all the landing zones, policies, proactive cost management, monitoring, and so on. Not to mention work needed for any advanced stuff on top of those foundational requirements. Expensiveness. Because it's time consuming, it also costs money, internal or external. Quality. Since things are done uniquely and are rather complex, there is no repetition, which means that there is room for errors. Shortage of experts. As we know, we are in skill resource limited market at the moment. There are many reasons for that, but one of them is that even our senior experts need to do basic stuff, even routine tasks regarding cloud. This is not the optimal way of using scarce skill resources we have. And finally, employment of juniors. Too often, the leap is way too high for junior staff because you need to build cloud for the customer or organization basically from scratch, which requires a lot of expertise. As an analog here, I would be using building a cloud, and like you have to have carpenters or construction workers to build house for you from long goods without advanced tools. And to make it more complex, so wants also everyone else. And they of course need to also have carpenters or construction workers to build houses for them. But Imagine if houses could be built in factories with advanced tools and automation. Whoa! Could we think cloud in the same way? We have seen that yes, we can. So, what is then the solution? First, how to overcome slowness. With the help of automation and pre-built modules, we can be even 100 times faster than when building things from scratch. This applies to recurring needs. Of course, there are needs which are unique or not that often recurring, but those are the cases where we definitely need experts to work on the problem and needs case by case. Just like when building a house, you need carpenters or construction workers to build the details or special needs you have that couldn't be built in the factory. Secondly, how to overcome expensiveness. Simple math. Less time equals less expensive. That's pretty obvious. Thirdly, how to improve quality. Utilizing automation, modules, existing code base, and so on means we repeat the job, and it means we can apply better quality measures to those jobs. Just like in a construction, for example, if you apply a template, you can saw faster and with better quality than if you would measure the length individually and saw individually. Next, how to overcome shortage of experts. To avoid using scarce skill resources to basic stuff and routine tasks, we can instead automate them. Just like in a factory building houses, one can apply automation for repetitive and routine tasks, and expertise can be saved for more complex problems. Finally, how to overcome employment of juniors. Leap needs to be smaller than it's nowadays. In general, modifying existing requires less competence than creating new. This gives a smoother path for juniors to grow while creating also value to the organization. With the help of automation and modules, we can help juniors to create value while they learn the technology and more advanced stuff. Again, just like in a factory building houses, there are tasks that are not too challenging for juniors, but match their skill levels. Moreover, they have opportunity to learn new tasks once they master the previous ones, and all the time they can create concrete value. So then there was the problem and the solution. So how we can achieve all these solutions and help organizations in their cloud adoption? We believe that if we combine forces, share knowledge, views, best practices, we can achieve synergy for the society, which is more than just the sum of its parts. We at Solita are committed to creating impact that lasts for a better tomorrow. And that's why we are here today to discuss the topic with you. All right, that was my introduction and ambition motivation for today's webinar. And then let's give Jose stage, and he will tell you more about current and future state of cloud automation. Jose, please.
Okay, sure. Let me just share my screen. Okay. So yes, switching gears a little bit here, like as Kimmo was talking about this, how we can share things as a community and so forth. So I'm going to be talking about infrastructure as code and what does that mean and how it actually can help us achieve more. But before diving into infrastructure as code, just a couple of words about myself. So my name is Jose Juhala. I work as a solutions architect at AWS. I have been working with AWS for about 2 years now. Before, I have been working in data center environments, working with virtualization, networks, storage systems, what have you, in these like more traditional data center environments. And after that, building cloud environments, moving applications from on-premise environments to cloud, and also doing cloud consulting. So I have basically seen my fair share from both sides of the like the infrastructure, so from the on-premises and the cloud. And what interests me is the infrastructure, networks, and actually everything that pretty much goes around the application, and also making it all as automated as possible. So working in code or various templating languages. And what does that actually mean nowadays? Like when we are talking about infrastructure and how to deploy that to AWS in this case, for example, there are multiple different options how to go about. And what we have seen previously, what we have been using, for example, in on-premises, and what is usually the easiest way to get started, for example, when you are deploying cloud infrastructure, is doing that manually. So just open up the console and start clicking through the environment and creating your resources that you need. Of course, that is time consuming, so it takes a lot of time to actually go through everything and create everything and so forth, but it is relatively easy. And hopefully we get some kind of a documentation out of it, that what we actually did. But the thing there is that it is pretty error prone, and we need to do it over and over and over again when we do new environments. So yeah, that's the error proneness in that application. Of course, it's hard to keep up with the documentation that, okay, what has been changed. The other option is doing different kind of scripted options, but also with that, we are a little bit like reducing the repetitive work, but still we need to take into account multiple different things, like how different pieces go together and so forth, and we need to handle that one. So if we want to have a little bit more easier option and reduce the repetitive work somewhat, we can go into the declarative fashion, how we can describe our infrastructure. And there are a couple popular tools like AWS Cloudformation and HashiCorp's Terraform that are widely used for describing the infrastructure, how you want it to be in your environment. And that is good. We have reduced the repetitive work here, and we have enabled a little bit more like this kind of documentation aspect that, okay, now we can see what there is. But that is quite verbose and requires still quite a lot of work to be done. And what we are basically seeing in the future and now is people and customers going more towards these kind of like abstractions over the declarative languages. So talking about AWS CDK and Pulumi, for example. And in this presentation, mainly focusing on the AWS CDK part. And again, as I was a little bit like explaining on the last slide, why infrastructure as code. So these are a couple pointers, definitely not all of those, like why is that like a good way to go. So for example, reducing the repetitive work, so we don't need to do everything all the time again and again. And thus we can reduce also errors. So when we define something in templating languages or in code, we can define it once, and we can make sure that there are no errors in it. It works as intended. And then we can basically enable the collaboration between teams, for example, or between the community, between different organizations and so forth, once we have that one declaration or code piece that we can share between each other. And also that enables us to be faster development when we can share those code pieces, and we don't need to create those from scratch every time or reinvent the wheel in a way. So just walking through in this presentation, like a one example architecture and how the infrastructure as code can help out here. So this kind of architecture where we pretty much have a simple architecture. We have like a VPC, which is like a AWS virtual private cloud, where you can define your private network that you can use inside your AWS account. We have a couple availability zones where our application is hosted. We have a application load balancer there that is load balancing web traffic towards our containerized applications, which are living in Amazon Elastic Container Service that is hosted by AWS Fargate. And then we have a container image registry there. So only a few pieces, but still there are quite a lot of different aspects that we need to define and create. And if we are creating multiple of these environments, it all starts to add up. There's quite a lot of configuration to be defined, for example, in our network configuration, or how the containers are running and how all of these like connections between these different services are working. So creating this manually is definitely taking a lot of time and error prone. So how can we improve on this? So we can have our different options, as we were talking about, for example, the Cloudformation and CDK. And with Cloudformation, we can define this infrastructure as these kind of templates, as there is just a small sample of it. So for all of the AWS services that we have and resources, we have a Cloudformation definitions, how we can define that, what kind of different configurations goes with each of these different services, and we can put all of that together. And that is a good piece. So for example, in this kind of an example, we only have here the code commit repository. We have a VPC, a one subnet, but then again, that is just a start for this infrastructure. So there is going to be quite many lines more of this documentation. But then again, this is already a documentation, and we can define it here in Cloudformation and share it between multiple teams, and that is a shareable artifact. But can we do basically more and actually reduce how much work we need to do to, for example, define VPC, which is quite basic construct that we need to create quite many times when we are creating AWS solutions and infrastructure. So nowadays, what we are like actively developing and customers are using more and more is AWS Cloud Development Kit, so AWS CDK for short. And what this is basically like a software framework where you can define your AWS infrastructure using the language of your choice to create the infrastructure as code. So as we can see in this example here, which is like just a small snippet, we are defining like VPCs and clusters and services in TypeScript code. So you can use your own code language that you like, for example, TypeScript, Python, Golang, C# and whatnot. And what we get out of this is that we get all of the support from our IDE, so we can get helpers like what kind of properties we need there and what attributes are available. We get these abstractions and same defaults for our like environment. And this really helps us to like develop faster and create our infrastructure in shorter period of time and share this. And how the CDK actually works is that the CDK consists of basically these three core components. So what we have is the core framework, which is built around the CDK app, and under which we have stacks and resources. So how we can think of these is that the stacks, CDK stacks, are basically one-to-one mapping to your AWS Cloudformation stacks. So if you have been defining infrastructure in Cloudformation, these are pretty much the same. And then the resources, each of these stacks can have one or multiple resources that gets deployed to your AWS infrastructure. All of this is built around the idea of constructs. Going into constructs a little bit more in the next slide. But basically, constructs define your AWS resources or multiple resources together. And then we have AWS CDK CLI that enables us to use CDK to create our CloudFormation stacks from our code base and also deploy that to our AWS account or multiple accounts for that matter. So a tool that enables us to, or the framework that enables us to create our infrastructure in code. So as I mentioned, the constructs and what does that do to enable us to be faster and more efficient. So AWS CDK has this thing called constructs, and there are 3 different levels of constructs that we have. So the level 1 constructs are basically your one-to-one mapping to CloudFormation resources. So when you are using these are exactly the same as you would be using CloudFormation. So if there are any required properties and so forth, you need to specify everything here. And for example, in our example of creating a VPC, we need to create our VPC, we need to create our subnets ourselves, the route tables and all of the pieces. And this is just a small sample of what there needs to be using the level 1 constructs. So that is not probably what we want, as we could also be using CloudFormation. So what most like CDK users are using nowadays is the level 2 constructs, which are like an abstraction over those level 1 constructs. So for example, creating an VPC, we have a level 2 construct that can actually create all of that on the left-hand side and much more for us automatically using basically like sane defaults. So what we need to do is define a CIDR range that we want to create, and it will take care of actually creating us a default VPC or default kind of VPC with public subnets, private subnets, nothing if we want, and so forth. And that is a whole load of reduced amount of code. So the left-hand side is only a few lines. There was bound to be more, like all of the subnets and route tables. That is not enough still what there is. And with this level 2 construct, we get everything with this single construct. And then moving on to level 3 constructs, and what does that give to us is actually a patterns. So as I had the architecture picture in the start, where we had these at the load balancer there, we had a couple ACs, we had Fargate and so forth. All of that definition in the CloudFormation would have been like 800 lines of code for definition. What we can do in CDK, or is this thing highlighted in yellow? So we have ECS patterns where we can actually call application load balanced Fargate service. And we can define it that, okay, we have a ECS cluster and we have some image options. So in this case, we are using Amazon ECS sample image, and this takes care of all of that. So it will create us elastic load balancer, create all of the definition code listeners, target groups, whatnot is related to that one, Fargate services and log groups and the configuration. So this really enables us to move faster with CDK. So we can use these higher level constructs to define pieces of infrastructure that we know that, okay, we need this kind of structure multiple times when we are creating our applications. And yeah, this enables us to create these kind of things. So we can create these by ourselves. This is not something that is just created by the AWS CDK team, but you can also create these yourself. So to collect multiple different L2 constructs together and create an intent-based construct for that. And what does that mean for the community and sharing part? We have, for example, AWS CDK Construct Hub, that we released a few months ago that enables the CDK community to create these higher level constructs that can be different kind of things. For example, in this, there is like a CDK GitLab example that somebody has created a construct for and shared for the community. So we can create our own constructs. We can share those between our own organization, or if we think that that is something that could be relevant for multiple organizations and actually share that wider, you can use, for example, AWS CDK Construct Hub and share your constructs for the wider use. So, as a summary, creating infrastructure as code gives us a lot of benefits. Even if you are doing it, for example, with CloudFormation and describing your environment in templating languages, that is already a good start. We don't need to do everything again and again, so we can reduce the amount of work that you need to do. But then again, you can go also towards the abstractions, more or less like AWS CDK, to get even more benefits out of it. There are multiple tools to do this. I only touched like on a couple tools like the CloudFormation and CDK part, but again, of course, there's like multiple tools from our partners and whatnot. For example, Terraform and Pulumi that you can use. So whatever suits your needs. And then coming back to a question that I get asked quite a lot, that does everybody need to be a developer now to create these kind of things? Yeah, you can be a developer from the infrastructure side also. So use AWS CDK and start defining everything in code. But you can still just, for example, use the CloudFormation way and use these more kind of like declarative languages. So you can, but no need to be switching all over to like coding now. But yeah, that concludes my part. Thank you all.
Okay, great. Thanks, Jose. It was very interesting to hear your thoughts. And now, should you have any questions to Jose, please type them in the chat and we're going to answer them in the end of the session. All right, and then next Santtu will tell you more about value creation for customers and how to empower cloud technology as a tool to work like a factory that builds houses. Santtu, go ahead.
Okay, thank you. Interesting talks. Hello all. Something from myself. My name is Santtu Seppänen. My educational background is in Masters in Embedded Systems in University of Oulu. Back then I thought that I want to design embedded systems, code close to hardware. That was my passion. So of course I went to industry as object-oriented programmer, pretty far from embedded systems, but it was fun. I have done share of programming, scrum mastering, project management, team leading, but not a single project towards embedded systems. I'm kind of easygoing. There's no need to pönöttää, as we say in Finnish. Or another good phrase which I like is asialliset hommat hoidetaan, muuten ollaan kuin ellun kanat. My hobbies include ice hockey, volleyball. I'm coach for children's volleyball team. Renovating homes, apartments. That's my hobby. And for embedded systems, home automation. If you cannot do it at work, then we do it as a hobby. So what would I like to tell you about? As Jose told about reusable models in code level, here I want to speak you about models automation, reusing components more abstract and holistic level. So the same principles apply. The models are formal structures explaining the world around. As Kimmo said, when building a house, you don't need the most experienced carpenter or construction worker. And make it worse, if it was like that, everyone else would need the same guys too. It would be expensive. On the other side, you choose the certain model and modify according to the need. You have the way to build houses. You don't have to reinvent it all over again. Also, when you gain experience in business, you develop similar kind of models to handle all kind of situations. And I think that makes one senior. As software developers are eager to get our hands dirty. We love to speak about technology and, for example, metrics, coding, reviews, automation. Of course, you need the know-how. You need to implement the CDK constructs if you are AWS experts. But that's not the key to be a senior. The seniority is more about thinking and gaining from past experiences. When your thinking is logical, consistent, and based on experience, you will make wiser choices. To repeat myself, you need the experience. You cannot invent it from thin air. You need the arguments with your colleagues. You need the meetings with the client. For sure, you should and can study certificates. I have done so too. I have 2 pros in AWS. It is something important for consultants before you can show that you can actually implement. You can show that I have really done the certificates. But still, you cannot trust the experience. Being 15 years at the business, it is a still powerful feeling when you can almost predict the outcome, explain difficult things to the customer and your peers, and cooperate with the different and difficult situation and come to an agreement how things should be implemented. So as a senior, we should build value. I think this is the most crucial and important thing. You should not count the rows of code you write, but the knowledge you share, and always aim building value for the customer. This is the core of the DevOps too. Good things happen if we focus to be efficient of building value for the customer. It can sound harsh to focus on the customer only, but in experience and for study, it works. The study has shown that it works. It helps in your daily life too. And of course, the customer can be your client, your teammate. It depends from the situation to another. And how you can build the value for the customer. The first thing is to challenge your models. You have your kind of thinking, your self-made models from your past experience. I come from the deep technical background, and I tend to go to the customer and say, hey, you need this. You need the software to the cloud. We can implement that, and that's great. And even the customer could say that, yeah, can you take our software to the cloud? Well, okay, done deal, good project for us and good infrastructure for the clients. But here's the important part. Is the cloud the right solution for the business needs of the customer? Is the system that benefit migrating to the cloud? Of course, I lean towards yes, but this is the place for senior. We should ask what the customer needs, not what the customer thinks he wants. Of course, it can be the same, but we should think, we should open up our models to discussion. Good architecture and implementation is crucial, but we should not forget to put the customer at the spotlight. For next slides, I will be referring this study, the book Accelerate. It's a kind of a report of a study how can we apply technology to drive business value, how to measure performance, and what capabilities should we invest in to drive higher performance. Interesting topics on what I have experienced and personally took as a model from past experiences, and how the authors has studying and measured the same thing in scientific ways. So let's dig a little deeper on the technical side of things. As we reuse our models, we should also reuse code, scripts, processes, you name it. The same applies. Use models. In the study of the book Accelerate, they found keeping the configuration of scripts in version control correlated more on the company's performance over others than keeping the code in version control. Of course, everyone keeps their code in version control, so there's no competitive edge on that. That's, I think, the reason. But of course, all you understand that scripts in version control by itself is not a cause and effect. Meaning, if you put your scripts to the Git, the customer base and cash flow will increase instantly and you succeed on the market. That's not how the things work, of course not. The scripts in version control is an outcome for a way bigger process to find models to improve one's capability to build value. When you build value from C-level to developer and focus reusing the correct models, and you end up automating build, test, deploy processes. You end up using CDK and abstractions. You end up improving feedback loops. And of course, if you do that, you need to have your scripts in version control. And that's why the measurements correlate. If you have scripts in version control, you improve your performance as a business is good. And when you reuse, you should always try to productize. So make a product from the model you have done. You should challenge your models. Are these the right ones? Are we actually going to the cloud? Do the business actually want to go to the cloud? If yes, then we have a correct model to do that. Of course, the next customer, the next business case might be different, but still, if you keep repeating the models, productize those models. For example, if one has productized the whole cloud journey, you can quickly get into speed. Ready-made instruction, battle-proven implementation, and peer support from earlier projects will help you up to speed. Of course, you can onboard juniors when you have the right models. Technical solutions follow a model, meaning there are few ways of provision database, few ways to networking, few ways to optimize expenditure on the cloud. When we do not plan and develop everything from scratch, we build once again value for the customer. And then automate. Even seniors make mistakes and believe that's the most definitely an experience-based model. I have done my share. And based on this model, we choose to automate recurring tasks, building code, testing, making deployments. As a result, we speed up the feedback loops, have repeatable results each time, enable developers make quality code, save developers time to invest in automated tests. We test our infrastructure in the pipeline, and once again, we build value for the customer and is our own daily work at the meantime. So focus on the customer value eases up developers' daily work. Focus on building value. Feature not deployed into production is a waste. Feature waiting for 6 months for production is long forgotten by developer. So ease up, automate, deliver fast. We don't want to wait these 6 months for production. To perform, we have to deliver continuously. When we deliver often, we deliver in small chunks because we cannot do otherwise. That's like given. You surely want to have your piece of code tested, delivered to production before you forget what you were doing. Also, according to Accelerate, short-lived branches, trunk-based development predict performance. This is once again a correlation. If these processes are in force, then you will do more new work and not unplanned repair, maintenance, emergency work. Also, in developers' perspective, failures in small changes are far easier to fix than the massive deployment. Reliable automated test predicts performance, improves quality. In the picture you see how performant companies spend far more time in new work than in unplanned or rework. And this is study and has proven that this is the case. And I have the experience on the similar effects. But it's good to have scientific numbers on that. Here are some measurements the authors made. These are measures from different types of organization. Deployment frequency was something we discussed already. So deploy often, deploy small. Of course, lead time for changes is smaller because we deliver often. Mean time to restore is low when we have fully capable deployment and testing infrastructure in place. Change failure rate is low if we deliver easier, smaller, tested changes into production. So implementing models will ease up our life, it ease up customers' life, deliver more value. Everyone wins. Just think your models, think what are the correct one on the business case in hand. And it applies from the abstract level to the code level. Everywhere you should use models. So past experiences make us what we are. Think your own models you have crafted. Challenge yourself, interact, find out new models for building value. And then a little bit of a teaser. Does your organization understand and use the models? Does your organization productize and reuse the code base? Let's build value. Thank you.